Bismillahirrahmanirrahim. This video is on the request of a student from Belgium, and he has sent a very interesting question. So let's try to solve it. Question says, in the network below, 6 resistors are connected to the central node. So this is the central node and 6 resistors are connected here. And there are 3 direct current voltage source of 6 volts. So these are the 3 voltage sources. The resistance values are indicated next to each resistor. So like this is 3 ohm, 2 ohm, 1 ohm, etc. Determine the current I1, I2 and IV. Now this is I2. This current is I1, this one here. And IV is this current here. So we have to find these. Now the first thing I did was I marked the resistances R1, R2, R3. I gave them name. Also I changed the voltage source to what we are used to in the Asian region. This is a voltage source used in Europe, but we use this type, so I've just drawn it for my ease. And just keep in mind that the arrow out is the positive of the battery. So this is the positive here and this side is the positive. Okay. Now the first thing that comes into mind after having seen the circuit is to use the Wye-Delta conversion, but I will not recommend to use Wye-Delta conversion unless you have no other choice. And especially if you have to convert more than one network, like here you have to convert at least 3 networks to solve this, you should not attempt. Moreover, we are not interested to find the overall resistance or R equivalent, we are actually trying to find the currents. So straight away we reject the Wye-Delta conversion. The next option could be the mesh analysis. So we can draw the mesh current, but this way the question can be solved, but it will become very, very tedious because we will have 6 currents through these 6 loops and we have to solve 6 equations to find these 3 currents. So this is also rejected. What is the other option? Let's see. So this is our circuit, and if you look carefully, you can see it has shown VA, VB, VA, VB. That means he's hinting that you should be using nodal analysis technique. So let's try to do that. So in nodal analysis, I'm just starting from this point. So one node is VB, this one, and the other node is VA, and this common line is the common point here. So starting point is here. So the first thing we'll do is connect the batteries. We are connecting this V1 battery of 6 volt, and then with this we have 2 resistances, R1 and R2. So let's connect these 2. So R1 is connected with VB and R2 is connected with VA. And then we move to the next one, and you see R3 is also between VA and VB. So we can connect R3 between VA and VB. And this way you keep moving, we connect this source, and then, so ultimately you will get something like this. So you have all 3 sources, you have the outer 3 resistances and the 2 ohms resistance and 1 ohm resistance. So this is the circuit that we have to solve. Okay, and in that particularly we have to find this current I2, this current I1, and the current through the battery IV. One point just keep in mind that whenever we connect more than one batteries in parallel, the voltage remains same. That is, whether we connected 3 or 4 or 5, the output voltage will remain same as one of the battery voltage. So it is 6 volt, therefore the output will remain 6 volt. What is the advantage of the connecting more than one battery is that they can supply more current. Overall current will increase, or overall current drain from individual battery will reduce. Okay, and now if you see these three are in parallel, so we can combine them. It will be 2/3 this resistance. Similarly, these three are in parallel, 1 ohm resistance, so it will be 1/3. And similarly, these three in parallel, so 3 ohm in parallel will become 1 ohm. And I'm just taking one battery source because, as I told you here, that no matter how many battery sources you connect in parallel, the output voltage will remain same. So I'm just keeping here one for the simplicity. Okay, and now if you recall, this is a battery source between two nodes. So we have to apply the super node technique, if you remember. So this whole will be considered one node, and we'll write the KCL equation. So KCL is current entering and equal to current leaving. So this is current entering, this is leaving. And entering is starting from 0 to VB, so 0 minus VB divided by the resistance. And leaving is coming from VA to 0, so VA minus 0 divided by 2/3. And solving this, we find VA to be minus 2 VB. So this is one of the equations. We need another equation which is called the KVL equation of the super node. So in the KVL equation, we just consider the voltages. So the KVL equation will be from here minus VA, then plus 6V, and plus VB is equal to 0. And now putting in the value of VA in this and solving, we get VB to be minus 2 volt. And putting VB value here, we get VA to be 4 volt. So what we have achieved is that we have now find the value of VA and VB, and now we can solve this circuit further to find the currents. Okay, so this was our original circuit. Now we have put in the voltages, and we have to find this current. So it is easy, voltage divided by current. Similarly this one. So I2 is 4 divided by 2 ohm, 2 ampere. And I1 is 0 minus 2 volt divided by 1. This is also 2 ampere. The question is, what is IV? Now this was very puzzling for me. I could not guess an easy way to find this current. So I took help of the first-order simulation circuit, and I connected current source, current meters, and you can see the battery current is showing to be 4 ampere. So this was a help that the battery current has to be 4 ampere. Also I checked all the resistances, and across 3 ohm resistance we also get 2 ampere. So we have the 2 ampere current in these, 2 ampere current in these, and also 2 ampere current flowing through these. So this then helped me guess the technique, and that is that if we connect these two also in parallel with this, then we can have the desired result. And let's see how is that possible. Because you see, this is 6 volt. To get 4, we have to divide it by 1.5. And how can we get 1.5? If we have 2 resistances of 3 ohm in parallel. So let's see next. So this one I connected like this, and the easiest way I thought is to redraw this circuit by tilting this. So when you tilt it left, then you get this arrangement. Now from here, I1 and I2 have already found, but you can easily find that from here, that 6 volt divided by 3 will be I1, 6 volt divided by this 3 will be I2, but we need to find IV. So for that we have to find the total current, and for that we have to find the total equivalent resistance. This we had already found. So R equivalent is all these in parallel will give us 0.5, and so I total will be now 6 volt divided by 0.5, 12 ampere. So 12 ampere current is the total current at this point. What about the battery current of single battery? Well, let's see this logic. Since there are 3 sources supplying total of 12 ampere current, this means that each source will supply 12 divided by 3, that is 4 ampere. And so we can say that IV is 4 ampere. Now after having solved this, I realized that this is again slightly tricky, and in an effort to trying to find an easy way, I discovered, or I tried to adopt this technique. And what is that? Just like 3-phase circuit, where we take only one phase circuit and solve to get the answer, here also we will follow the same technique. So we'll just take one set of values. So we are taking one battery, one of these, one of this resistance, and one of this resistance, and with this we can easily find the current and the all the 3 currents. Here also we have to find VA and VB, and we will just follow the what is called super node method. So again we have already done, but just as a repeat, we'll find KCL from here. So KCL, same technique, 0 minus VB divided by now this 1 ohm resistance, and here VA divided by 2 ohm resistance, so VA is minus 2 VB. KVL also about this one, same equation we are getting. From here putting the value of VA, VB is minus 2 and VA is 4. So VA, VB, we have now got this for single circuit, which is same. So this is our single circuit now, and now we can easily find the currents. I2, 4 divided by 2, this resistance 2 ampere. I1 going from here, so 0 minus 2 divided by 1, 2 ampere. And now this current. For this we again tilt the circuit. So tilt the circuit, 6 volt, 3 ohm, and the summation of these two is 3 ohms. So this current is dividing into 2 paths, or we can just calculate the equivalent. 3 parallel, 3 is 1.5. 6 divided by 1.5 is 4 ampere, and that is IV. So I hope you have learned something from here, and it is up to you which technique you adopt. Please let me know through your comments if you like this video, and share it with your friends. Subscribe it because that is what I expect from you. Thank you.